Howdy, y'all. Okay, so I wanted to go through a few practice problems from 9.1 and 9.2, and there's no like questions over these. There's no secret question, like pop quiz question or anything like that. These are just going to be additional examples in case any of the ones from class confused you. So I'm going to start out by doing one of the examples from the textbook, which is to find the first 5 terms in the sequence. So this example is giving us a sub n is equal to negative 5n plus 1. And we know that this guy is going to be explicit because there is just an n. There is no a sub n minus 1 or any sort of consecutive term. In order to find the first 5 terms, we are going to create a little table. I'm going to have 1, 2, 3, 4, 5. And I'm just going to plug in these n's for this a sub n. Now notice, whenever you're doing a recursive formula with your a sub n minus 1, that's where you use the preceding number for the next one. But whenever you're using an explicit formula, that's whenever you use this value to the left in the n category into the right category. So we will do negative 5 times 1 plus 1, or negative 5 plus 1 plus a negative sign, plus 1, which will be negative 4, and we continue down the line. We do not have to know the preceding term in order to continue to find the first 5 terms. We are not given any sort of initial condition, that a sub 0 that we've been talking about. We have not been given anything like that. And so that is also telling us that this is explicit and not recursive. So I'm just going through and doing the math on these. And it's really not too bad, right? So for these, I just use the n values that were provided and plug them into my little equation. Now notice, if you're given something else, let's say that we are trying to find the first 5 terms in the sequence, and we've been given that a sub n is equal to a sub n minus 1 plus 2, then we have to have an initial condition first where we're given some a sub 0, and it says that it is going to be negative 33. So how does this work? Well, if I create a whole other n and a sub n category to have 1, 2, 3, 4, 5. Apologies, this guy's supposed to be a sub 1. Then I know that I can go ahead and put this guy, this first term, as negative 33 because that is a sub 1, or my initial condition. My next term is going to be a sub 2, so a sub 2 is going to be equal to the preceding consecutive term, so a sub 1 plus 2. That'll be negative 33 plus 2, or negative 31, and then I plug that guy in here. The next one, a sub 3, is going to use the preceding term a sub 2 plus 2, where my a sub 2 is equal to negative 31. I'm still adding that 2, and so I have negative 29. So negative 29 is equal to a sub 3. A sub 4 is equal to a sub 3 plus 2, which is going to be negative 29 plus 2, or negative 27, which is going to be my a sub 4. A sub 5 shouldn't be too hard now because we are just going to use the preceding term, a sub 4 plus 2, which is going to be negative 27 plus 2, or negative 25. So negative 25 is equal to a sub 5. And that's your answer. So notice how things are a little bit different. Whenever we have some sort of initial condition, all of these preceding terms are dependent on each other. So In this sequence, it is recursive because you keep coming back to the same points of this a sub n. Whereas you'll notice in an explicit formula, it doesn't matter which n we're starting at. We can start at n being 55 for all we care. We can still find an answer for this. Whereas in this problem, if we're trying to find a sub 55 or n is equal to 55, that's going to be a lot more work because we're going to have to find all of the preceding terms leading up to 55. This is a really good word problem. So Katie began the year with an unpaid balance of $300 on her credit card. Because she had not read the credit card agreement, she did not realize that the company charged 1.8% interest each month on her unpaid balance, in addition to a $29 penalty in any month she might fail to make a minimum payment. Katie ignored her credit card bill for 4 consecutive months before finally deciding to pay off the balance. What did she owe after 4 months of non-payment? So there's a few different steps to this, and the best way to do it is to just start at the beginning and write down what we know. So she has $300 starting out on her credit card. $300 starting. For each month, she is charged 1.8% interest. And let me try and color coordinate this so we can keep these guys together. So let's do yellow for our 1.8% interest each month. So 1.8% increase each month. There is also a $29 penalty each month as well that she doesn't pay. Then it's saying that we did this for 4 months. Holy cow. 4 months. That's a long time to ignore your bill before finally deciding to make the payment. So what did she owe after 4 months of non-payment? So let's think about what's going on here. So we're starting out with $300. Then we're adding some 1.8% each month. So 1.8% per month plus $29 per month. Let's see if we can create a formula to represent this. So we are going to have a sub n being equal to, we are always going to start out with that $300. Then we're adding 1.8% of that $300. So 1.8% is going to be the same thing as 0.018. Once we convert that percentage into a decimal, it's going to be 1.8% of $300. So I'm going to multiply that each time by $300. Also by whatever month it is. And I'm just going to put MO since I'm running out of room. And then we also have $29 that's being multiplied per month that we have. Well, the thing that's varying in this problem is what month it is. And if you look, we're also trying to find what happens at 4 months. So why don't we label this as saying a sub n, or our sequence, is equal to 300 plus, and I'm going to go ahead and toss in that 0.018 multiplied by that 300 into my calculator. So I'm going to get 5.4 Per month, well, month is our unknown here, so why don't we call our unknown, our month, N, as in our A sub N. And then we are adding $29 per month, which again, that month is N. Well, we have some like terms here, right? So why don't we try and combine those? Why don't we set that equal to $300 plus we've got 5.4N plus 29N. So if we add those together, we're going to have plus 34.4N. If we're trying to find what happens after 4 months, isn't that the same thing as finding A sub 4? Which is going to be 300 plus 34.4 times N. Well, N is going to be our 4. And then we put this in the calculator. So this is going to be 300 plus 137.6 or 437.60. That's how much we're going to owe in order to pay off our balance. What's terrible is that this is actually really accurate. And yeah, it will definitely shoot up that quickly after 4 months. So I thought that was a super good example. Now we are going to move forward into 9.2, where we have arithmetic sequences. I think we all enjoy arithmetic sequences more than our recursive or explicit sequences, just because they tend to be a lot easier and a lot more straightforward, where we're just trying to find our common difference of D. So let's do a couple examples of those. So let's say that we have this example, which is going to be to find the 32nd term in the sequence. So find the 32nd term. And the example that we're given is going to be the sequence A sub N is equal to 34, 37, 40, and 43. In a lot of cases, you won't even see that. You'll just see some numbers like this. Well, let's create our equation. If you remember from your notes, we continually use the little guy that says A sub N is equal to A sub 1 plus N minus 1 multiplied by D, right? Let's see if we can figure out the things that we know. What is A sub 1? A sub 1 is our initial condition or our starting point. And so that looks like it's 34. What is D? D is the difference between terms. So it looks like we're adding 3. So D is going to be a positive 3. And what is N? What is our question asking for? Well, it's asking for the 32nd term. So I'm going to be looking for A sub 32 being equal to 34 plus, I've got 32, which is N, minus 1, all times D, which is 3. So I have 34 plus 3 times 31. You can do the math on your calculator or just follow it through. So 3 times 31 is going to be 93. And then plus 34 is going to be 127. In this case, we used an explicit formula. And I want you to think about why we used an explicit formula. We had to find the 32nd term, but we were not given the 31st term or the 33rd term. We were given our first 4 terms. So we had to start back at the very beginning. So it's not very practical for us to use a recursive formula, because then I would have to use each preceding number, 34, 37, 40, 43, and build up until I get to the 32nd term, which is just not practical. We won't be able to do that. Another example that you might see is going to be the setup of find the 17th term And you'll just be given A sub 16 is equal to 18 and D is equal to 5. That's all you're going to be given. It's not what we're used to seeing, like a bunch of numbers in this way, but it's something that we can think about in a recursive definition, because if we're looking for the 17th and they give us the 16th number, then we should be able to go back through and say that whatever our preceding term is with that common difference should be able to find our 17th term, so long as we use a recursive definition. So anytime you see something like that, where you've been given the 17th term or asked to find the 17th term, but you've been given the 16th term, or anything that's close in that ballpark, you're probably going to use a recursive formula. Whereas if you've just been given the first few terms and then you're asked to find something off the wall like the 32nd term, you're probably going to be using an explicit formula. So if we are being asked to find the 17th term, then we would have some sort of recursive formula that would look like this. A sub n is equal to A sub n minus 1 plus D. The A sub n that we're trying to find is A sub 17. Well, the preceding term from A sub 17 is A sub 16, and D is going to be 5. So we're going to have A sub 16, which is 18, plus 5, making A sub 17 23. Lastly, we're doing this example that has to do with seats in a stadium. And yes, I did count the seats whenever I was drawing it. But the number of seats in the first 13 rows of a section of an arena form an arithmetic sequence. Rows 1 and 2 are shown in the diagram below, the really crappy one that I just drew. How many seats are in row 13? So let's figure out what we've got. Our first row, it says that we have 14 seats. So row 1 has 14 seats. Row 2 has 16 seats. And it's asking us to find how many seats are in row 13. So let's see if we can figure out the different components of an arithmetic sequence. So let's just look at an explicit formula, just because we are being asked for some random number like 13, and I'm not given row 12 or row 14 or something really close to row 13. So let me, because I haven't been given any hints about a recursive formula, let me try an explicit formula. So if I'm doing an explicit arithmetic sequence, then that means that I am using the definition A sub n is equal to A sub 1 plus n minus 1 times D. Let's see if we can figure out if we can identify any of these components. So A sub 1 is our initial condition. That's our starting point. Well, what are we starting with? We're starting with the first row. So we're starting with 14 seats. We are adding n minus 1, and we're multiplying that by D. So let me go ahead and see. I think we can find our D here, right? Because we are going from 14 to 16, and it follows an arithmetic sequence. Well, aren't we just adding 2? So wouldn't my D be 2? Now, lastly, our n is usually the thing that we're trying to find. So aren't we trying to find the 13th row? So our n would be 13. And then you just solve. So you have 14 plus 2 times 12. So that's going to be 14 plus 24, or that's going to be 38.